Here we go into the second video for u-substitution. In this one, we're going to go over just a couple more example types, just so that you've been exposed to some, well, of the varieties of u-substitution problems that are out there. This one gives you different instructions. It says solve the differential equation, which hopefully we know from past experience in lesson 4.1, that just means integrate this thing. So we're going to integrate both sides with respect to dx. That's how we solve this thing out if you want to get real technical. So then that'll give me y, because the integral of the derivative is just, well, the thing that came before it, y. And so now we've got the integral of 1/2 x plus 13. So we've got that formality out of the way. And the question is, why in the world do I use u-substitution here? You've got a function within a function. Now I'm going to rewrite this as the indefinite integral of 1/2 x plus 13 all raised to the 1/2. By doing that, I'm kind of set up a little bit nicer. So now the function within a function is often my u value. So I'm going to let u equal to 1/2 x plus 13. Now remember, we're aiming to get rid of all of the x's. So this will get rid of this, but we still have dx. To get a dx, I need to take the derivative. The derivative of this is going to be 1/2 a dx. And now from here, we got a problem. We don't have a 1/2 dx in here. So I'm going to multiply, and I'll insert a little 1/2 right there. But I can't just multiply something by 1/2, right? I can't give you $20 and say, you know what, that's only worth 10. It's a $20 bill, right? I can only do that if you say, give me back change for the 10, so that we even ourselves out if I want that 20 to be worth $10. So if I want this to still be the same value, I've got to multiply through by 2. That balances this out. So you got the 2, you've got the 1/2, and that's going to equal out to 1. Nice, so we haven't changed anything. Now we keep going. We've got the integral of 2 is just hanging out. 1/2 dx, that just became du. This is now u to the 1/2, not so bad. And now we integrate like normal. So u to the 1/2, its indefinite integral is going to be 2 times. We'll have u to the 3/2. Dividing by to the 3/2 is 2/3 plus c. And we'll end up with 4/3. 2 times 2/3. We'll plug back in for u. 1/2 x plus 13 raised, don't forget about that 3/2 to the 3/2 plus c. And of course you could check your answer. If you take the derivative of this, you're going to end up back here, which is beautiful. And I encourage you as you start out with u-substitution to check all your answers with the derivative. I did that in the first video. I'm not going to do that in all of them, just so that you see, that's why it works, or that's how we get back to checking our answer. All right, that's it. That's the u-sub for that one. On to the next one. Integrate and check your solutions. Don't mind if I do. So I've got 2 more examples here for you, and then we'll call it a video. So here, yes, we've got an x on the outside, but we've got this inner function here raised to the 3/5. That, for me, is going to be u because it's the inner function. It's a function within a function. And its derivative will be 14x. It's got an x, which is going to go nicely here. So I let u equal to 7x squared minus 1. The derivative of that is going to be 14x dx. Ooh, we don't have a 14x, we just have an x. Put in a 14, right? So I'm going to put that here, just because there's more space. 14x dx. But I can't just multiply by 14. That would change the value of this. I will at the same time multiply by 1/14, or divide by 14. Now I've essentially multiplied the whole integral by 1. Okay, so now from here we're going to do some substitution. The 1/14 hanging out. Now I've got that x, 14x dx, all of that is equal to du. U is all of this inner function. It's nice, right? Once you get to that point, the integration's not so bad. So I've got 1/14 times u to the 3/5, you add 1 to that, u to the 8/5. And then that's going to be times 5/8, or divided by 8/5 plus c. And then when we simplify that down, it's not going to be pretty. You'll get 5 over, let's see, 80 and 32, 112 is what that ends up being. Yeah, that's nice. And then we're going to resubstitute back in for u in terms of x. That's 7x squared minus 1 to the 8/5 plus c. And if you don't believe me, take the derivative of your answer and you'll get back to that. It's beautiful. All right, this one's a little bit gnarly. You've got, a trig function squared of 2x and then sine 2x. Now, I think it helps, especially in these kinds of problems, to rewrite the cosine squared as something that's been grouped, meaning something like that, times sine of 2x. I think that makes it a little bit more clear what it is that the innermost function is. So you have cosine of 2x squared. Now, even though the derivative of sine of 2x is cosine of 2x with a 2 on the outside, it'll only cancel out one of these cosines, meaning the derivative of this is not this squared. So picking this to be u wouldn't work. And if you did, you'll see that you've got more stuff left over, and therefore you'd have to pick a different u. So no sweat if you pick the wrong u. Pick a different one if it doesn't work out nicely and give you everything in terms of u like it did here. So I'm going to let the innermost function equal u. That's cosine of 2x. Oh yeah. The derivative of that we need to find dx. du is, well, the derivative of cosine is minus sine 2x. Now don't forget the chain rule times the derivative of the inside, 2. I don't know why I left that space there, but it did. So, we're missing some stuff here. Let's just rewrite that. And that's that dx, just squeeze that in there. That's minus 2 sine 2x, just rewriting it, dx. We've got the sine 2 dx, but we don't have the minus 2 that we have here. So I'm going to multiply in by a minus 2. And if I multiply in by a minus 2, I've got to divide, or multiply, if you will, by the reciprocal, negative 1/2. That then equals 1, and so we're good to go. So I've got the minus 1/2. This is u. Negative 2 sine 2x dx, all of that is du. Look how simple that gets. This again is u. Beautiful. Don't forget about the squared. And now the integral feels good. Negative 1/2. The integral of u squared is u cubed over 3 plus c. From there we multiply up, you'll get minus u cubed over 6 plus c. And that, once we substitute back in for u, is cosine of 2x with the minus on the outside. Cosine of 2x, and I'll put all of that cubed. You could have put the 3 here as well. All over 6 plus c. Oh, it's beautiful. I'm going to check this answer just so that you can see how this works out. So let's do the check. The derivative of the outside, that 3 comes out. Cosine of 2x, all of that squared, all over 6, times the derivative of the inside, minus sine 2x, times the derivative of its inside. That's a bad derivative. Times 2. 2 times negative 3 times negative 1 is positive 6. All of this is positive 6. And you're left with cosine of 2x squared times sine 2x, which is exactly what the problem had to start in the integrand. Isn't that beautiful? Give it up for u-substitution. I'll see you in the next video. More variety for you. I hope you're starting to get it down. Peace.